seen that video.
Tayson, will you please read the first paragraph for me?
In the previous task, how do you know that? We stated that we saw how the following diagram can be constructed by rotating a triangle about the midpoint of its two sides. The final diagram suggests the sum of the three angles of... Yeah, I'm not prepared for school. The sum of
You're doing great.
The sum
Keep it up.
of the three angles of a triangle is 180 degrees. This diagram tells a story because you saw how it was constructed through a sequence of steps. You may even have carried out those steps yourself.
Excellent. We sure did.
I have a dream that you would
Shh. All right, Hadassah, you can read the next paragraph, please.
Sam, I love this. No.
I also do. That's good.
Sometimes we are asked to draw a conclusion from a diagram when we are given the last diagram in a sequence steps? It's a sequence of steps. Hold up, grammar. We may have to mentally reconstruct the steps that got us to this last diagram, so we can believe in the claim the diagram wants us to see. They're trying to propagandize math. I don't like this.
How did you go from laughing to just
So-
serious?
Question number 1 says, for example, what can you say about the triangle in this diagram? What do you guys think? What claims can we make about this triangle?
Well, okay.
Okay, so William said that it looks equilateral, right? That's what you just said too, Sam. All three sides look the same.
Speaking, as long as those are bisectors, it is equilateral.
What do you mean bisectors?
Okay, so A and B, those points. So C to the other C, if A is in the middle of that, bisecting it, right? Splitting it into two equal. And same with B, then that's where, the triangle would definitionally be an equilateral.
Okay. But when we don't have the other point on the other side, how could we say it without that? If we think that that's true. What else is happening in this diagram?
Okay, are A and B in the middle of the two circles or no?
So you just said a very key word. There are circles in this diagram, right? Mm-hmm. A and B are, in fact, so A is the center of one circle and B is the center of the other.
Okay, then definitionally speaking, yes, because the radius of each of the circles is going to be equal throughout the entire length of the circle.
Correct.
Length to a circle? I don't know, words.
Throughout the entire circumference, you could say the length of the circumference,
So A
sure.
to B would definitionally speaking have to be the same distance as A and B.
So A to B is a radius of each circle A and circle B, right? That means those circles are the same size, which means all radii of both circles are congruent. So when we look at AC, is AC a radii of circle A?
Yes.
Or a radius of circle A? Yeah, it is, right? So that means that AC is congruent to AB. What about BC? Is BC a radius of circle B? Yeah, so that means that it also has to be congruent to AB. So it's congruent to AB. AC is congruent to AB, and AB is congruent to CB, right? What does that then have to mean about AC and BC also?
AC and BC.
They all have the same.
Yeah, they're also going to be congruent.
Congruent, equivalent, equal. Why are there so many words for shapes and lines?
So equal is technically the measures. Their distances are equal, but their line segments are congruent. Excellent. So we think it's an equilateral triangle. I would write that down for number 1.
Why you gotta be aggressive?
Nah, he's hyping us up.
Yeah, get hype, yo. Sheesh.
I feel like it's 4 times.
I'm going.
What convinces you that you can make this claim? Well, we just talked about it, right? So I would like, can someone kind of synopsize what we just spoke about so that we can write this down?
Okay, so those two circles, right? You know how they kind of like meet in the middle.
Mhm.
So the A is the middle of that.
A and B are radii, right?
That-
Let's say that.
Yeah.
AB is a radius.
Yeah, and I'm trying to think of English words. Tayson has rubbed off on me too much.
Let's go.
Jacob, do you have a thought you can add to that? If A and B are, or if AB is a radius?
If A and B is a radius, that would also mean that A and C would be a radius along with B and C.
Yeah, so all three of them are radii of two congruent circles. That means the radii must be congruent. Good. Thanks for starting us off there, William.
Things rubbed off on me. I had a stroke and a half in the middle of that.
You're all right.
I had like 17
They all
strokes in the middle of trying to read that.
None of you had any strokes. Please stop saying
It
that.
was a mental stroke.
They're all mental strokes. What you had was not a
Mr.
stroke.
Ball knows that he puts these on YouTube, so he's over there like, and we're all like, yeah,
Well,
we
it's
had
just
a stroke,
also-
and Mr. Ball butts in a video game.
In a video. I mean, like, it's
Not
also
real.
something to be thoughtful of people that actually have had strokes or know people. Like, it's just, like, consider
Hey,
it.
My great uncle, his heart exploded in his chest.
What is that? How does that
What does that
happen?
have to do with it?
Like it actually like boom.
Just burst?
I
Yeah.
think this one.
How? What happened?
He had really, really, really bad heart problems.
Dang.
Yeah.
So he's no longer with us?
No.
I'm sorry for your loss. Okay, number 3.
This class went down.
What is the sequence of steps? Here's the question now. What is the sequence of steps that you think led to this diagram? I will give you step number 1, and I want you to see if you can extrapolate this. Step number 1 was this right here. Point A, or line AB. That was step number 1, is line AB was drawn. So what do you think happened from that point?
I think they found the radii of AB, and then they took that line and they drew it, starting at point C, which would be that intersection,
Okay.
the non-midpointal intersection.
How do we get an intersection though?
You have to make the radii of
Oh,
the
they drew a
circles.
circle.
So they used AB as a radii or as a radius, and Jacob just said this also.
Between the radii.
If you use, so here's what happens. If you were to use a compass, right? Do all of you have compasses? I need you to get that and bring it in for Wednesday. Okay?
Aha,
You don't have one?
I'm smart.
Like the little math, like that.
Oh yeah.
Math compass. Yeah.
Sorry, I was like.
No, you're okay.
Mine
We're going on an adventure, and we need compasses. Everyone needs one.
The compass yesterday was not fun.
I'm sorry, please don't do that anymore.
It was
You will need compasses for this class, okay? So just make sure that you've got it. Okay, so if we were to use a compass, we could set it to radius length AB and scribe those circles around point A and around point B. Then, what did we do to get point C?
You just do where they intersect.
Exactly, they just looked at where they intersected at the top
Circumference.
and then connected the line from C to B. Circumfry is not the circumference, plural.
What's the plural of circumference?
Circumferences.
I think circumference better.
Circumferences.
It just makes me hungry.
Circumferences.
Why?
Okay, because fries. Potatoes. Okay,
I'm not going with you guys.
here we go. So that's number 3. That would be the steps for how you get this diagram. And then we know actually also that this is an equilateral triangle. So can you go ahead and write those things down also for steps of number 3? Put them in your own words.
Okay, line
Nate probably won't be
What?
the way I described it, how to do the steps. Kind of makes sense, but we'll see what it does.
Oh, got it. I thought you said there won't be a ton of mistakes, but you said makes sense. I was like, good on ya. No mistakes. Nice. Amen, brother.
Why?
That's why we gotta practice.
Look like that.
Shh, Hadassah. Shh, Hadassah. Hadassah.
Nasty.
It looks like a kite.
It's awful.
Oh, thanks for that.
Nein, das ist schlecht.
Wait, what?
Okay. Number 4, what can you say about the triangles, quadrilateral, or diagonals of the quadrilateral that appear in the following diagram? List several conjectures that you believe are true. It also gives to you that circle A is congruent to circle B, and which we could have made that claim anyway, right? Because the radii are congruent, so we know that they must be congruent. But I want you to think about this on your own for a little bit, okay? And then we're going to come back together and discuss. So come up with a couple of conjectures about this quadrilateral or triangle or diagonals, anything you want to say about that, okay? So come up with maybe 3 each. And write them down. And then we're going to talk about them together. Come up with 3?
I'm thinking of the third.
Ah, very good. Very good. God bless you.
I think that was a call.
Oh.
Small.
What kind of sneeze sounds like that?
Interesting.
You alright?
No.
You got 3?
I got like 5.
W, okay.
Jason, can I borrow one of those?
Nope. Okay, I'll give you another 30 seconds.
This dude has too much time on his hands. It's not snowing, at least not yet.
Can you read minds? How did you know? That's what I was thinking about.
Is it supposed to snow?
Probably it's Idaho.
No, it's not supposed to snow. Okay. Although in American Falls, it looks like it might be snowing right now. All right. So let's talk about. I'm going to take one conjecture from everyone. We're going to start with William. Tell me a conjecture,
I
William.
have no idea what conjecture means.
That means why didn't you ask? It's what you were doing.
I-
It means a statement that you believe is true.
Oh, okay. 4 right triangles.
Oh, very nice. So that means a couple of things, right? He says 4 right triangles. What does that mean about
P
those
equals
diagonals?
90 degrees, or 90 degrees.
Yeah, so those diagonals, they are perpendicular to each other. So that actually kind of comes from this other idea that the diagonals are perpendicular. So we would say we think the diagonals are perpendicular.
What about P equals 90 degrees?
We could say P equals 90 degrees as well. Yep. Actually, even if we just said P equals 90 degrees, that would mean all of those things. Because if this is 90, this is a linear pair, this is a linear pair, these are vertical angles. Have we talked about vertical angles yet? Oh, we're going to. It's going to be so good.
Very going to.
Vertical angles
Anyway.
are fun if you use them properly.
It's just like everything. It's good if you use it right. Most things. Almost everything. Yes, Sam.
2 equilaterals.
Oh, where do you see those?
You have A, C, and B, which is 1, and then A, D, and B.
Nice. 2 equilateral triangles.
Triangles?
Hadassah.
C is congruent to D.
Okay, so that whole angle we think is congruent. Which if they're both equilateral, then it would have to be, yeah? Mia?
They all equal 90,
What equals 90?
the triangles.
True. That has been taken. Do you have another one?
No.
Okay. All of yours have been taken too? Okay.
More.
Tayson, tell me what's another one.
Ooh, I got 2 really good ones.
Okay, so if you're looking for more ideas, you could potentially consider one of these.
Want
Maybe.
me to tell you both of them, or just
Start with one, and then I'll go to Hadassah and then come back to you.
Okay. CD is perpendicularly bisected by line AB.
Oh. So we think that this is congruent to this, and that this is perpendicular.
Yep.
Okay, interesting. Next one, Hadassah.
A, B, C, D is equal to 360 degrees.
Okay,
Should
true.
be. I also have another one.
Okay, sounds good. We'll go back to Tayson and then come back to you.
Okay. Ooh, so
Do you have any more?
angles words CAD,
Mm-hmm.
CAD, and the angle ACB are, what's the fancy word for when they equal 180?
Supplementary.
Supplementary angles.
So CAD and ACB.
Yep, those would be supplementary angles.
So this and this.
Yep.
Huh. Okay.
Oh, yeah,
That's slick.
what's
Nice.
equal
Well, yeah, because it's just half.
If they're just equilateral triangles,
It
then
would be
yeah.
the same for the.
Okay.
Yeah.
Qué interesantes.
Mm.
AC is congruent to BD, isn't it?
Yeah, very nice.
And AD is congruent to BC.
Ooh, okay. So we have, now we're talking about this and this, this and this. What kind of shape does that make?
That makes a parallelogram.
Makes a parallelogram. Do we know that they're all congruent to each other?
Yes. So it's a rhombus.
Ah, so it's an even
Yeah,
specialer
rhombus.
parallelogram. We could say that AB or ACBD is a rhombus. 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 So you could even say that as one of your conjectures. I would say write that down if you don't have it written down, because that's a good one.
I have mine cut off and then I've been writing it.
Nice.
I'm like, okay.
Sam, did you have another one?
No.
Okay. Hadassah, did you have another
I
one?
don't think I
Or was that it?
For the record, I did do more than Tayson. so
Oh
I'm
my
proud of
goodness.
myself.
I am so glad we're
Proud of
keeping
myself.
score. I'm glad that you're proud of yourself.
Like, it'll like break.
Okay.
Easy to write.
Awesome. Unfortunately, in this scenario, having more is not great because you are going to prove every single one that you wrote down.
Oh, that's not bad.
I'm just
I have
kidding. You're not
five.
going to prove all of them. I'm
I
just
have five
teasing.
down.
I have all of them. That would be so.
So we're going to select. Excuse me. We're going
Cover your mouth.
to select one of these conjectures and write. They say a paragraph to convince somebody else to do it. So I want you to think about one of your conjectures. Okay, and you, as we did up here, how we explained that we have a radius that is congruent to another radius that's congruent to another radius. They're all three congruent. That means it's equilateral. You're going to do that same process in words to pick one of your proofs.
That's easy.
Yeah, that's really.
God bless you.
Does it literally have to be an entire paragraph?
No, you can just kind of, you can, it's more than bullet points, but less, so it doesn't have to be absolutely formal, but
Yeah, this is math class. A paragraph as long as you need it to be.
that's true. Some math textbooks have some thick paragraphs in them. It's like,
Terrifying looking one.
it's true.
Have
All right.
you seen that one sentence that just has nothing but prepositional phrases, and so it's like an entire book long?
Oh, that sounds.
Aren't there are like 107 prepositions, I mean.
Okay, he reuses prepositions.
Oh, prepositional phrases.
Yeah, prepositional
Oh,
phrases.
gotcha. Dang.
It is ridiculous.
That sounds kind of
And
awful.
it's all one sentence.
That sounds true.
Okay.
Run-on sentence.
Okay, proof.
Okay.
How many did I say? There are 107 prepositions?
Something like that.
Let me see. Dang it.
108.
150.
I was close.
That must have gone up.
It probably has. This is English language.
Yeah.
Of course.
I took a test one time that I had to memorize 107 prepositions.
Why?
I got a 99% on that test because I spelled through the preposition through THREW instead of THROUGH. That was in 8th grade, and I have remembered that ever since.
You
I
had
was
to
so
memorize
upset.
107 prepositions in 8th grade?
Yeah.
That's stupid.
Wait, hold on. The-
That's stupid.
I mean, it's what got me where I am today. That's all I gotta say.
I had a
High school
biology
math
teacher in
teacher.
like the 7th grade that made me memorize all the bones in the human body.
Oh,
In
that's
7th grade?
It was terrifying.
Like,
And
There are
before,
so
we
many.
missed a ball in
Science
fourth
teacher.
grade. We had
Sweet.
to memorize all the books in the Bible, Old
Ooh.
and New Testament.
W.
I remember like 2.
Dude, I'll bet you could name more than that right now.
Leviticus.
Boom.
Zechariah.
2.
Okay.
Why is Leviticus the first one you went with?
Deuteronomy. Ruth.
Yeah, boom.
Joshua, Judges.
wait, what are we listing?
Genesis.
Numbers.
I already said Genesis.
Books of the Bible. Bibles.
Psalms.
Oh.
Hey, Psalms. We have
John,
What comes
Matthew,
after Judges?
Okay,
What comes after Judges?
Acts,
Is it a quadrilateral? Is that what they're?
yeah, four-sided figures. Okay, we are going to, you guys are really, really good and impressive at naming your Bible books. I'm proud of you and I appreciate you for that. Do your work.
Can I say mine?
Not yet. All right, we are cruising. So here is one more diagram. Describe the sequence of steps that you think was used to construct this diagram, beginning with the figure on the left and ending with the figure on the right.
Charlie, they do the triangle.
What's it called when, wait.
They chose an arbitrary point on the y-axis and then drew lines connecting the endpoints of both of the two lines of line AB to the new point they chose.
So I apologize. What they meant here is they meant start with describing the figure on the left and then describe the figure on the right.
Oh.
Yeah, it's not a greatly worded question.
So
So how did they do the figure on the left?
they have the x-intercept. Is that what it is? Is it like an actual like graph thing or is that?
No, this is just a picture, just a diagram. So, yeah, Jacob.
Do you think they could have done like the circle thing again and then later erase the circle?
Yes, I think that's exactly what happened because if we think about it, aren't those lines AB and CD? Right? That's kind of like what they are. Because we had said we think that this is a right angle, and we had kind of alluded to the fact that we think AP and BP are congruent, right? So,
That's a reference
I
you won't get.
don't
It's an
think
inside
so.
joke between me and my mom.
Okay, definitely not in the same way.
Don't question it.
It might be an eclipse, not ellipse, that's it.
an
I
ellipse?
think it would be a circle.
What? What would be a circle? What? Oh, if you were to do this?
It's an egg.
That's a big.
Well, but what if you just did the circles that we had talked about on the previous page?
Yeah, I
Just
think
you
like-
put a,
give
yeah,
you
you
the
do.
shape shown,
You put your
because
compass on the point
if you
A
look,
and
the
on a
circles have to
and
produce an equilateral triangle.
yeah, and then put one on point. Yeah.
What if we just, oops,
and
wow.
They're a
don't
bit
produce
goofy,
an
but they got the
equilateral
spirit.
triangle.
What if we just connected, I really am sorry about the poor drawing. What if I connected this point and this point? Don't those lines, that line kind of lands right there? So they're not talking about, what about if I connected like this right here? Wow. Why can't I make that turn? They're not talking about that necessarily. They're just saying, how did I get to here?
Can I say mine?
They erased the circles.
And then they would have erased the circles. So what they did was from segment AB, construct two circles with radii AB, right? One at center A, one at center B. And then where those lines intersected, they connected those points, and that's that perpendicular bisector, right?
Okay.
That's, I think, what they did. So you need to now describe that. Write that down. And then you can also say, but they erased the circles.
That's what I said.
But is that good?
Drew two circles. Found the radii. Oh, you're talking in the past tense. Okay, I thought it was just a typo. A righto? Got it. That's perfect, Hadassah.
Good.
Well done. Well
my best.
done. What about the second figure?
They did the same thing and then just found
Well, how
the,
did they get C?
well,
C
they
is
found
the-
C by
It's
finding
not a
where the
circle.
top circles intersect.
That is,
Did they?
not be the
No.
case.
Did they? Or
Because
no?
wouldn't that would make it equilateral triangle?
It's not an equilateral triangle. So
Jason, are you sick?
no, I'm dying.
Excuse me.
Almost
I
like-
To
thought you,
sneeze.
like, I think you had water in your mouth or something. You're like, just like.
No.
That was weird.
Oh,
Do you guys
A
know?
and B, do they go like all the way out to the sides of the circles instead of just where they, the radii?
Yeah, no, but point of
Mm-mm.
circumference wouldn't equal that.
Mm.
Yeah, Jacob.
Because it has the two lines that are in the middle. What if they did circles from there? Would that have worked?
Oh, that could be.
Wait, those
What if I told you? Hey, are you guys familiar with the word arbitrary?
No.
Yeah, that's what I was saying. They chose an arbitrary point, and you said no.
I really?
Well, okay. we
I did
talked
not
about
hear
the
you
first
say
one.
that.
We were talking
Well,
about the
kinda.
first one.
Kinda.
Okay. I did
Oh.
You said, oh, you might not have said no in terms of it's not arbitrary.
You said
That's
it was-
yeah. That was not my intention,
Okay,
at
I
least.
said it was an arbitrary point, and I think you said no because we're working on the first one. But
Oh, gotcha.
I did say they chose an arbitrary.
Well, very good.
point.
I'll have to re-listen to this recording and see if I can hear you and
And
formally
listen to your
apologize. Maybe I'll write you a
spaghetti
letter.
Story.
Your
I don't wanna
spaghetti
listen to that
where you
story.
roll your body out.
Okay.
Don't edit
So,
that out.
will you describe for us what an arbitrary point is?
An arbitrary point is a point that is chosen just because, like you just pick something. There's no rhyme or reason behind it.
Yeah, the only rhyme or reason with this point is that it's on that line that's vertical. Other than that, it's arbitrary as to where it is on that line. So it does not matter. You could pick any point on that line. Okay, so they just picked a point on that vertical line and connected it, called it C, and connected the endpoints A and B to it. You should write that down. Very good.
Travis and Tahani are back.
You bet they are.
They're doing their math homework. Wow.
Can't believe Tahani from The Good Place is in her math assignment.
I don't think that it's the same
I
person.
have no idea who that is.
Yay, we're almost done.
Can't believe none of y'all
Okay.
see The Good Place.
So, very nice. Will you read through somebody those?
I will.
Thank you.
I shall. Given that Tayson's not doing so well with that.
Tayson did great.
I did.
Travis and
terrible.
Tahani are doing their math homework together. One of the questions asks them to prove the following statement. The points on the perpendicular bisector of a segment are equidistant from the endpoints of the segment. That is, should not be phrased as a question at all. Travis and Tahani think the diagram above will be helpful to prove this statement, but they know they will need to say more than just describe how to create this program. Blah, blah, blah. Travis starts by describing the things they know, and Tahani tries to keep a written record by jotting notes down on a piece of paper.
Very nice. So, Travis is explaining stuff, and Tahani is trying to make this in shorthand as well. So, we're going to, in number 8, record the symbolic notation of what Tahani may have written to try to keep track of T. Ravis's statements.
Wait, but wouldn't that statement just be true definitionally? Right, the point would have to be equidistant because it is a bisector, and bisector means that both other sides are equidistant.
So, perhaps, but we are going to take the steps to try to prove this now.
Definitionally.
Well, it's once we prove it, then we can say it's part of the definition. But you can't, like in math, a lot of these things, we need to prove why it's part of the definition, or we need to prove why it's true. So a lot of Module 5 is going to be us taking these things that up to this point we have said this is just the definition, it's true because of that, but this is explaining why it's true. So in this table, we're going to copy basically Travis's notes like Tahani's doing, but putting them into notational form where possible. Okay, so you can see that the first one of Travis's statements, he says, we need to start with the segment and its perpendicular bisector already drawn. So Tehani says, draw segment AB, locate its midpoint M, and draw a perpendicular line L through the midpoint. Then Travis says, Bill, what does Travis say?
I just would. What does Travis say?
Bill, what does Travis say? We need to show, it's the second one.
That we need to show that any point on the perpendicular bisector is what's that word?
Equidistant. That's a tricky one.
Equidistant from two endpoints, so I can pick any arbitrary point on the perpendicular bisector. Let's call it C.
Very good. So that's kind of what we described. Those first two steps are the process that we described in our paragraph above, right?
That's a goofy paragraph.
So then Tehani says, pick any point C on line L. Then Travis says, we need to show that this point is the same distance from two endpoints. How can we show that? Sam, how do you think we could show that? Or what are we trying to prove? That any point is that this point is the same distance from the two endpoints. Graphically, this point is the same distance from the two endpoints.
Oh,
What would we have to say?
wouldn't it be?
If this is the same distance from A and from B, what does that mean about A, C, and BC?
That they.
Yeah, that they're the same, right? They're congruent. So what we need to prove then is that segment AC, did I say MC or BC earlier a second ago? I meant BC. So segment AC is congruent to segment BC. That's what we're going to try to prove.
BAD.
What?
BC and AD. You know how James work, right?
Yeah, I do. Oh, got it. I heard PC and I was like, what? I don't understand. Okay, now Travis says, let's see, Mia, will you tell us what Travis says? T-Rav.
If we knew the two triangles were congruent, we could say that the point of the perpendicular bisector is the same distance from each endpoint. So what do we know about the two triangles that would let us say that they are congruent?
Very nice. So what should we first prove then? Before we can prove that, we need to first prove that the triangles are congruent. How do we say that symbolically?
Where?
Triangle.
Triangle ABC.
Triangle.
Let's call this midpoint M.
AMB.
So let's name them. Triangle AMC is what?
So draw an equal sign and then a squiggly above the equal.
And a comb over.
Rowan
See theaters?
And
Is congruent to...
triangle BMC.
Okay, why did you say BMC? If it's AMC, why did you also say BMC?
It's on both of them. It's like the y-axis.
It has to be, M has to be in the middle of both of them. They have to be in the same direction. Corresponding parts need to be in the same places.
Exactly, because you have the angle of AMC and BMC that has to be equivalent.
Mm-hmm.
Bro, I still think I'm like shaken up from going and seeing the new Avatar in theaters. I'm not gonna lie. I don't think I ever recovered.
Sorry to hear that. We need to continue focusing on the math for now.
Speaking of AMC theaters.
Nice. Okay, we know that both triangles contain a right angle.
Yeah.
Well,
How do we say that? Not graphically. How do we say that? Symbolically. Thank you.
I feel like I know how to do this. I just don't know how to put it into words like it's asking.
Well, now we've got to put it into words. This is what we're learning today. That's great. Jacob?
Angle AMC. Would it be congruent? Would we say it's congruent to angle BMC?
We could say that, and that they're equal to what?
90.
So let's say they are right angles, because we have to say that they're right angles before we can say that they're 90, right? And as soon as we start talking about degrees, that's a measure of an angle. So if we start talking about degrees, then we have to start talking about the measure of angles. What's the next one? Sam.
You want me to read it?
I sure do. Please.
We know that the perpendicular bisector cuts segment AB into two congruent segments.
Oh, so AB is cut into two segments. What are those segments?
Congruent.
They are congruent. And what are they? You're absolutely correct.
Is it?
What else are
Is
they?
it
What are their names?
and BM?
AM and BM. How could we say that more mathematically speaking?
Second.
Very good. Segment AM is congruent to segment BM. Very nice. And, oh, we just read that one. Jacob.
Obviously, the segment from C to the midpoint of segment AB is a side of both triangles.
Obviously. So, what do we need to write there symbolically?
Sass.
That
What?
No. Right there. It's the side of one of the triangles. What is true about something with itself?
It is congruent to itself.
It's congruent to itself. So we're going to say
C is congruent.
MC
MC. Why not CM?
is, sure, you could do CM, is congruent to MC. You could also say MC is congruent to CM. You could say CM is congruent to CM. Oh, I should have said segment MC is congruent to segment MC. That is the proper
MC.
mathematical nomenclature. Mathemagical. What?
An A or B week.
B.
Oh.
So cold in here.
Okay, so the triangles are congruent by SAS.
Science.
So what do we say?
So the triangles are congruent.
Triangle.
We will,
The thing in the
Oh,
first
side angle side.
Oh.
but before, we should probably make the statement of triangle congruence, right? So now you can make that statement because we have said an angle is congruent, a side is congruent, and another side is congruent. Except for the angle lay between those two sides, right? So now we've got side angle side. Sias. Just gonna eat a whole bunch of candy and get all fat and sassy.
Segments AC and BC are congruent.
You know that video? You don't know it?
Sounds delicious.
You give off these from vibes.
Segment AC is congruent to segment BC. I'm giving you what kind of vibes?
This is Trinidad from Hairspray.
I don't know
Hairspray.
who that is.
The mother
The
in
musical.
Hairspray.
You can
And-
flamethrower out of hairspray.
Why could we say this? AC is congruent to BC. What's the reasoning behind that? We've said congruent triangles.
Actually,
Because
segment
AM is congruent to BM.
Actually, you are correct. Say that again.
Because segment AM is congruent to segment BM.
So it's because of all these things, but there's a very specific name for why we can say that a part of a triangle is congruent to a part of another triangle. Do you guys remember it?
Triangular cohesion. I don't know.
I'm gonna write it. Are you ready? You're not ready.
I'm never-
Are you ready?
Nope.
Sir.
Congruency.
It's not a word.
CPS.
Kentucky Fried Chicken.
CDC.
CDC.
Oh, CPCTC or whatever.
Oh,
Congruent parts of
The
congruent
CCCT.
triangles
C.
are congruent.
No.
CPCTC.
Yeah,
Right?
I don't memorize
The
this.
CCCT, no way.
I don't remember it.
Someone, yeah. So
Congruent perpendicular
Corresponding parts of
triangles.
congruent
Oh.
triangles are congruent.
let's right now write this down, okay? Corresponding parts of congruent triangles are congruent.
Okay, so it's kind of going down into question 9, but it has the spirit, Mr. Ball.
Samesies.
Yeah, that's not.
I'm just writing.
So corresponding parts of congruent triangles are congruent. That I think about it as that, like, to help me remember this, is CPCTC. I think about as it, like the C is being split apart by paper towels.
I just think about it as P and
C's
T are
with P and T
being broken
between
by
them. Get it?
C's.
Get it?
Oh.
See, you're splitting the C's with paper towels.
Ha 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 ha. Or Mr. Ball.
Orange juice.
OJ?
He's a bit goofy, but he has a spirit.
I dig OJ. Sometimes. It's okay.
He thinks Travis is brilliant.
Tahani thinks T-Rav is brilliant, but she would like the ideas to flow more smoothly start to finish. So now what you need to do is arrange Tahani's symbolic notes in a way that someone else could follow the argument and see the connection between ideas. So having it flow a little bit more simply. You know what I'm chill with? I'm chill with if we were to just put numbers beside these rather than all of like rearranging. So what should we do first? What's the first thing in any proof?
Draw a.
What are you proving?
Locate
It's the given,
Oh, yeah.
which would be this first one up here. Hadassah was talking about it. Drawing AB. Yeah? Number 1?
Do you know
Yep.
there's
Just
one,
list them down.
Is it
2
already
minus 1. That's not.
Yeah, isn't it already?
And then.
No, because these ones are kind of out of order. We don't need that right now. Next, we know that we need to get to those points, but before we can get to those points, we got to say all this other business. So what else can we say next, Jacob?
Would it be that segment A is congruent to segment B?
Yeah, so what are the next 3 steps we should say, do you think? Yeah, the one that I have in brackets right now, we should state these 3. Why do I need to state these 3 before the next thing? What does it prove?
It proves that triangle AMC is congruent to B.
Yeah, so we have to state those 3 things first, and then we can state that the triangles are congruent. What order we state those 3 things actually does not matter. Okay? So, there we go. So I'm going to just say that these things are statements 2, 3, and 4, but that it does not matter. I'm making that big bracket to show it does not matter the order in which we state them.
W.
So remember, as I'm going through this, remember about things that you could be using for this for in the future. So remember, if you're ever wondering, like, what do I need to put next? Sometimes order does not matter in a proof. Sometimes it most definitely does, right? But you've got to be cognizant about this. Again, let me reiterate, order does not matter with these 3 because they are all coming off of the given, but it matters that they come before the triangle congruence because we need them to prove triangle congruence. Now, with those 3 down, what can we say about step number 5? Or what is step number 5?
Prove.
That AC,
Prove.
or segment AC is congruent to BC.
Word.
Wait.
Sorry. No,
Isn't it the proof?
I was not listening very well.
Yeah, apparently AC is
Yeah, both
congruent to
make what?
BC. So it's that third.
Dadgummit, I'm sorry. I don't know where I was at.
Which one is it?
What are you doing? What's
Where are we at?
the
One.
So can we say that AC and BC are congruent? Why?
Because we haven't proved everything yet.
What else do we need to prove?
Triangle.
The triangles, that they are congruent.
Dumpskis, fat dumpskis.
Well, that was very confusing.
I'm sorry, I have no idea what I was thinking about. I don't.
Since when you have you 5 here,
I'm sorry,
I
Sam.
don't care. It's fine.
And now, because of that,
You can have CP,
I'm just not
CTC.
talking.
no, stop. No, I want you to speak. I'm so sorry. Oh, then because of that, yes, we can say the segments are congruent because of CPCTC. That's my L for today. That might be my low for this week.
Not
Just-
the
You just cut off the
spaghetti in the
seeds.
sink. That's not. It's
Oh,
not up there.
You're right. They're
That's
both.
a close
Yep.
second.
Okay, what's next?
Number one.
I don't know why I wrote a Y there.
Why?
Here.
Bill.
What is that?
Y'all never seen that before?
That was a triangle.
My brain went to a bowling ball.
I know.
So these three dots, they express a sense of finality in a proof. So when you are done proving something, you can go ... and your proof is
Why not just make
finished.
it an ellipses?
Well, what about?
Because an ellipses implies a lack of finality,
Oh, I guess it's just information. That's what it's proof.
right?
So one dot always has to be above another. Didn't know that
The
grammar
social
could be
class.
so,
Oh my goodness.
so
Okay,
incredibly.
number 10. Would this justification be true regardless of where the point C is?
Yeah.
Why?
Because all of those points are based off an arbitrary.
Yeah.
Yeah.
There was no point C, like, specifically given.
Yep. They are all based off of an arbitrary point. You should write that down.
How do you spell?
I'm guessing A-R.
How do I spell what?
T-R-A-R-Y.
Arbitrary.
I got
Arbitrary? Ooh, good question. Are you ready?
Did I do it right? I'm gonna be so proud of myself if I did.
Why did it stop? Oh, I think my pencil just died.
Yeah, I was at like 12% when you started, so.
That's really sad. Well, I guess that
Use your finger.
It's in.
I can't.
That's so
It's
stupid.
in the second.
Well, I can.
Write it on the board.
Ah!
Write it on
It's,
the
it's in
board.
the second Travis thing.
Just spell it out.
Whoa.
This is not going
Yeah,
well.
write it on the board.
Write it on the board.
Write it on the board.
Here we go. Ready?
I spelled it right.
Hey, with us emojis.
What on earth are your most used emojis?
What?
There you go, let's go.
You know, I thought mine were
Oh no, bird.
Burb.
Mine are
No,
special.
because
Might be
mine
fun.
have changed
Jason,
so
mine are
much
guaranteed
ever
worse
since
than
I
mine.
met Beagle,
I know
because I
mine
just
are
use
special.
them so much
All right.
more.
Do you know my
There's
random?
The end.
Like me.